So thank you very much. Good afternoon, everybody. Firstly, we would like to thank the organization for inviting Revertia to participate in this interesting seminar. Where are we going? Especially to the municipality of Genova as main partner in this in the wind model project, and of course to Ana Rita for being so kind with us. My name is Alejo Calatayud, and my partner is Alejandro Lajo. We are both working in Revertia, so we are both going to speak and to explain what's Revertia, its primary purpose, and well, the main tasks we are involved with. Afterwards, we will show and we will explain our live project, EcoRae, in which we have participated in consortium with the University of Vigo. Vigo is a city in Galicia, in the region of Galicia, and a technological center. And of course, we will highlight the more significant results of this project that end up last year in July, and this is the result of the project, with the actions of the project. Okay, Revertia is a Spanish company founded in 2010, and its primary purpose is to provide services in the management of waste, electrical and electronic equipment to all sorts of both public and private organizations. We are authorized by the Spanish Public Administration as a center for preparation for reuse. Indeed, we were the first center authorized in our region. The start of Revertia is linked to the increasing consumption of electrical and electronic equipment, which has resulted in corresponding increase in the generation of WEEE. Although we provide services to all types of waste, electrical and electronic equipment, our company is mainly focused on obsolete computer equipment. So we opted to reuse them as the best treatment options in accordance with the European principle of hierarchy in waste management. As you know, it's reducing, reuse, recycle, recovery, and finally disposal. Many of these equipments can often have a second life. So in line with the idea of circular economy, we try to recover them and make them reusable. When this is not possible, of course, we send them to recycling, to different recycling plants. Okay? Last year, we managed 140 tons of WEEE and get to reuse at 20% of total waste managed, avoiding 250 tons of greenhouse emissions to the atmosphere thanks to our reusing activities. Okay, we will explain later the tool that was created in the framework of the EcoRae project. So briefly, these management services include WEEE collection in customer facilities, transport and transfer to our plants, certified elimination of all the information and data contained in its hardware, repair of equipment, and if not possible, as I have said right now, sending it to different recycling plants with which we have collaboration agreements, while ensuring full traceability of the process. And finally, there is a reused electrical or electronic device. In our case, it's computer equipment, reused computer equipment, whose destination can be the sale in the secondary market, of course, with all the warranties of functioning, or the donation to social projects if our customers want to. One of the most innovative aspects of our range of services is the carbon footprint analysis we carry out. This allows the positive impact on the company's CO2 emissions to be quantified, resulting from the reuse of obsolete computer equipment compared to the manufacture of new devices. This is possible thanks to the EcoRae project, as we will explain right now. Therefore, in Revertia, we try to transform a legal mandatory on waste management in an opportunity to obtain positive impacts on sustainability and social responsibility corporate. It's clear the environmental and social benefits of the reusing, but it's essential, as you mentioned before, an appropriate selective collection and also an appropriate storage, avoiding these devices, in our case, computer equipment, can be damaged. So, well, as you know, as main environmental and social benefits, we can mention these ones: reducing waste generated by ensuring a more rational use of natural resources and raw materials, many of them critical; saving the emissions of greenhouse gases; promoting responsible consumption; generating investment and creating new centers and networks for reusing, and therefore creating new jobs, in this case, green jobs. And finally, but not less important, accessing to people with fewer economic resources to computer hardware, reducing technological gap. Obviously, we assume commitments and principles derived from the European legislative framework, which is made up, as you well know, by the European Directive 2012, transposed a year ago into the Spanish law by a royal decree. The Spanish royal decree includes specific targets for preparation for reuse from 2017, with a target of 3% in the case of computer equipment and small telecommunications devices, and 4% from 2018. So Spain is the unique country with the Belgian region of Flanders to establish specific reusing targets separated from recycling. As you know, as key principles in the management of waste, we have the principle of hierarchy in waste management, and of course the principle of extended producer responsibility. This means that the producer also has a responsibility for the management and financing of waste. Okay, the Corrae project was the 6th of the 35 European Union projects selected from the 2011 Life Plus program within the environmental policy and governance sub-program. With the leadership of the University of Vigo in association with our company as a management operator and Energy Lab as a technological center, was a 3-year transfer project with a budget close to 1,300,000 euros. This project arose with the purpose to offer solutions to improve the problem of a category of WE, the derivative of computer equipment, from a feasible way in terms not only economic and technical, but also environmental. The general aim of this project consisted of characterizing and demonstrating an industrial process for reusing electronic equipment to promote standards that guarantee the correct implementation of European law and contribute to a high level of separation of WE. Our role in this project was to show the economic feasibility of the processes of reuse of computer equipment from a private business point of view, and demonstrate the replicability of the project on a larger scale than in the demonstration. Nevertheless, we also participate in the rest of the actions of the project as the life cycle assessment of a complete computer equipment, as Alejandro is going to explain now. The specific objectives of the EcoRae project were as follows: compare the environmental impact of a reuse versus a non-reuse scenario, define a reuse preparation process and ascertain the resources needed, establish the mandatory requirements during the reuse preparation process outlined in a guide of proposed regulatory improvements and technical standards to be applied, assess technical and economic feasibility through 4 demonstration process, as well as evaluating environmental and policy implications, raise awareness among all those involved in the process regarding the preference for WE reuse over recycling, and finally, ensure correct implementation of European regulations regarding WE reuse, increasing application. Okay, so now Alejandro is going to talk about 2 of the project actions of EcoRae.
Thank you. Well, my name is Alejandro Lajo. I'm CEO at Revertia, and I was also responsible of this project, Corrae. I was the coordinator of all the different actions in which Revertia participate. I'm going to tell you about two different aspects of this project. I think two of the more important ones. The first one is the LCA, the Life Cycle Assessment. I'm sure this is the more interesting result that we achieve. The objective was the undertaking and understanding of the LCA life cycle assessment of a reuse process. Our functional unit, is important to say, that is a full computer equipment. That means a CPU, a screen, a keyboard, and a mouse. All the analysis was made following the ISO procedure, and it's also it also consider all the different phases of the life of an equipment. That is the first of all the extract of the raw material, the manufacturing of the product, the shipping of the equipment, the first use of the product, and the last one, the disposal and recycling phase. As a specific objectives, basically is the assess the impact of in the different phases by identifying and characterizing potential impacts that could take place in any of them. How? Comparing two scenarios. One scenario with a reuse process and the other without reuse. So if we compare the two scenarios, as I just said, we have the first one, the A, in which we have an equipment that once is completely used by her first owner, pass a reuse process in order to be again used by another consumer. And we have the other scenario in which after this first life, the equipment is discarded and recycled without passing for this process of reuse. Here in this chart, you can see, this part of the analysis was taken by Energy Lab, research center of the University of the Vigo University, and it was to make this calculation. They used a specialized software that needed to have data. We were collecting data during 1 year in our pilot plant in order to know all the inputs necessary to have this calculation. For example, the energy consumption, the number of devices that were treated, the resources needed to this treatment, the number of reused equipment that we achieved, but also the subproduct, I mean the waste that all the equipments that couldn't be reused. So with all this data, there were 9 categories that were analyzed. We are showing you here the category that is more understand and more visible for us is that one of the climate change, that it's measured in CO2 kilograms equivalent. So as you can see, for each of the different phases, of the life cycle, we can see that in the first three there are the manufacturing, the shipping, and the first consume, and the first use. Two scenarios are exactly the same. Dark blue, you have the scenario without reuse. The soft one, the scenario without reuse. Is in the fourth stage that you can see a difference between the two scenarios. This scenario with a reuse, I mean the situation in which we have reused equipment instead of a new device, is you can see it's a large difference between one scenario and the other. That is also that could be also be seen in the phase of shipping, because normally reused devices are going to the local area. In the phase of energy consumption, is the only one in which we can see that it's better to have a new equipment than a reused one. That is because of the more efficiency devices that the producers are creating, that need less energy than the ancient ones. And the last phase is similar for the two scenarios, the recycling, that is the recycling process. So the results is a reduction of 199 kilograms of CO2 kilograms is possible once we have a reused equipment. I remember an equipment for us is a CPU, a screen, a keyboard, and a mouse. So, once we have arrived to demonstrate the feasibility of the environmental feasibility, we have as our last point, but not less important, for me that's key, the economic balance. The aim of this phase was to also demonstrate that this activity could be interesting for different companies to develop a business based off the reuse of electronic equipment. So we also developed a tool that allows us to formulate different scenarios and using the standard cost method. In the scenario we choose, we calculate the direct cost and the indirect cost. Direct cost, that means workforce, transportations, and consumptions. We arrive to the number of 6.1 euros per functional unit. It's very important the fact that transportation costs are 65% of the direct cost. So we have to take a look of the we have to try to avoid transportations of waste to the reuse facilities. So the first classifications in the collect points is fundamental. The indirect cost, suppose environ 21.4 euros per complete computer. So we have almost 30 euros of direct and indirect cost. If we take a look of the revenues, into the sample we had in the pilot experience, we could find a price of sale that 40 euros approx. So we have a positive margin of more than 10 euros per reused computer. As a clear conclusion, we have arrived to a scenario in which the reuse of electronic equipment and CPU screen, keyboard, complete CPU is possible and environmental and economical in environmental and economical terms preferable than only recycling. I hardly recommend. You can find more information in our website. If you have any doubt, don't hesitate to contact us. And I hardly recommend you to take a look at the social benefits of this activity. That was a study that the economic department of the university, of the Vigo University, did, and it's really interesting. Thanks so much for your attention.